Welcome to the Deep Dive. Today, in the world of computer science and software engineering, we're looking at something pretty big that landed on August 5th, 2025. OpenAI just released new open-weight language models, GPT-OSS 120B and GPT-OSS 20B, and this is a huge deal. They're OpenAI's first open-weight model since way back with GPT-2. So our mission for you today is to really get what makes these models significant. We'll look at what they can do, how they were built, and, the bigger picture. Okay, so let's unpack this. The core announcement, it really shifts things, doesn't it? We're talking state-of-the-art open-weight models designed for real-world performance, but crucially at low cost. And they're under the Apache 2.0 license, which is pretty flexible. The key term here is open weight. You get the actual model parameters, the brain, if you will. That's different from just open source software. It gives developers way more freedom to run, inspect, customize, basically. Much more transparency and control.
Exactly. And what's really striking is their capability versus their efficiency. It's quite something. The big one, GPT-OSS 120B, it actually achieves near parity with OpenAI's own A4 Mini on reasoning benchmarks. While the smaller one, the 20B, performs kind of like OpenAI's O3 Mini.
Wow, near parity. So open models are really catching up then.
It certainly looks that way. And the efficiency, the 120B model, it runs on just a single 80 gigabit GPU. And the 20B model, which is great for edge devices, needs only about 16 gigabytes of memory.
16 gigs.
Yeah. Think about it, local inference, rapid testing without needing massive, expensive server farms. This could be huge for, say, startups or researchers in places where cloud compute costs are a major barrier. It really does level the playing field.
That efficiency is pretty staggering.
Yeah.
Especially for edge. But does running locally like that? Does it introduce any security or maybe data privacy concerns compared to using cloud APIs?
That's a fair question. But actually, running locally can often boost privacy and security. Your sensitive data doesn't need to leave your own environment, right? No sending it off to a third-party API. Plus, these models are strong on tool use web search, running Python code, and things like agentic workflows. They support full chain-of-thought reasoning, structured outputs, you name it. And, sort of unexpectedly, they did really well on HealthBench. The 120B even outperformed models like GPT-4o and OpenAI o1.
Better than GPT-4o on a health benchmark.
Yeah, which kind of challenges the idea that proprietary models always dominate specialized fields. But, and this is critical, they are absolutely not a replacement for actual medical professionals. Need to be very clear on that.
Okay, incredible capabilities. But I'm really curious, how did OpenAI manage this? Packing so much performance into open models that run on, well, relatively normal hardware. What's the tech magic?
Right, so they're transformer models, that's the base. But the key is the mixture of experts architecture, MOE. Instead of one giant brain trying to do everything, you can think of it as having a team of specialists. For any input, the model only activates the few experts best suited for that specific task.
Ah, so it's more efficient because only a fraction is active at any time.
Precisely. That 120 billion parameter model, it only activates about 5.1 billion parameters per token. It's just calling the needed specialists. They also used advanced pre-training and post-training, including reinforcement learning, focusing heavily on STEM, coding, and general knowledge. And another interesting bit is the Harmony chat format. It's important for following instructions well. It lets you, the developer, adjust the reasoning effort low, medium, high, depending on the task. Need a quick answer? Low effort. Need deep thinking, high effort. Optimizes speed and accuracy.
Okay, it makes sense. So moving from how they work to the implications, safety is always a huge concern, especially with open models that anyone can download. How's OpenAI handling that?
Yeah, they've stressed that safety was foundational right from the start. It wasn't an afterthought. They did comprehensive safety training, like filtering out potentially harmful CBRN data that's chemical, biological, radiological, nuclear during pre-training. They also use something called deliberative alignment, where the model learns to sort of reflect on its outputs and potential harms. And crucially, they tested specifically fine-tuned versions of the 120B model for malicious uses, like biothreats or cyber attacks. The finding was that these models did not reach the high capability risk thresholds defined in their own safety framework.
That's good to hear they tested for that. But, once it's out there, open models could still potentially be misused by people outside controlled tests, right?
Absolutely. That's always the challenge with open releases, and transparency is part of addressing that. An interesting aspect here is their approach to chain of thought, the CONT-T. It's unsupervised. This means the model's internal reasoning steps aren't safety aligned in the same way the final output is.
Why do that? It seems risky.
Well, it's actually critical for developers who need to monitor the model's behavior. It gives them an unfiltered look at the thought process, makes it easier to spot and fix problematic reasoning. But the warning is clear. Don't show these raw codes directly to end users. They might contain hallucinations or harmful stuff. And to get the community involved, they're running a red teaming challenge, offering, I think, $500,000 in prizes to find safety issues.
Right, harnessing the community. So wrapping this up, what does this all mean for you, the listener, in the broader AI world? These aren't just cool new tools. They really complement OpenAI's hosted API models. They broaden access, lower barriers for maybe smaller companies or folks in emerging markets, and hopefully spur more innovation globally. It feels like a big step for safer, more transparent AI development, empowering, the whole computer science and software engineering field. Makes you think.
It really does. I think the big question hanging in the air now is how will the whole AI community take these accessible, powerful, open models and use them? How will they push beneficial AI forward in ways maybe we haven't even conceived of yet?
Exactly that. A question to ponder. We definitely encourage you to check these models out yourself. They're on Hugging Face, and OpenAI has an open model playground. Thanks for joining us for this deep dive into the evolving landscape of open weight AI.